In example 3, we've got to try and solve this quadratic. So we can actually solve a quadratic like this fairly simply by rearranging it to get z on its own. So we know that z squared is equal to minus 9. Well, we can square root both sides to get z is equal to the square root of minus 9. Well, if we had an equation such as x squared equals 16, we know that when we solve this, we're going to have two solutions. Either x equals the square root of 16 or x equals minus the square root of 16. Well, here when we square root both sides, we're going to have z equals the square root of minus 9 or z equals minus the square root of minus 9. Well, to work out the square root of minus 9, we don't really leave our answers with a negative underneath the square root. We always try and get our answers in the form a plus bi, so with an I in it. So here we're going to write this as root 9 times root minus 1. So here we're going to get z equals root 9 is 3 and root minus 1 is I. Or we're going to get z equals minus 3i. Let's have a look at example 4 then. So we've got a quadratic, again, that we're trying to solve, but this time we can't rearrange it to get z on its own. So we're going to have to either use a quadratic formula or complete the square. So let's try and use the quadratic formula. If we use the quadratic formula, we're going to get x equals z equals minus 6 plus or minus the square root of 6 squared minus 4 times 1 times 25 all over 2 times 1. So let's try and simplify this a little bit. We're going to get z equals minus 6 plus or minus the square root of minus 64 all over 2. So again, we want to try and write this complex number in the form a plus bi, real part plus the imaginary part I. So to do that, let's try and split it up into two fractions. So we've got minus 6 over 2 plus or minus root minus 64 over 2. Minus 6 over 2 is minus 3. Root minus 64 can be written as root 64 times minus 1. Root 64 is 8 and root minus 1 is I. So we can write root minus 64 as 8i. So we've got plus or minus 8i over 2, which I'm going to write as a half times 8i. So we can simplify that further. That's minus 3 plus or minus a half times 8i is 4i. So we're going to get two solutions, either z equals minus 3 plus 4i or z equals minus 3 minus 4i. That's using the quadratic formula. We could also complete the square to solve this equation. So if we complete the square, let's write it in completed square form. So that could be written as z plus 3 all squared plus 16 equals 0. And now we've got it in completed square form, because we've got only one occurrence of z, we can try and rearrange this to get z on its own. So let's take over the 16 to the other side, take away 16 from both sides, and let's square root both sides. So we get z plus 3 equals the square root of minus 16. Well, because we've square rooted both sides of the equation, we've got another solution, which is z plus 3 equals minus the square root of minus 16. Let's try and simplify the square root of minus 16. We could write square root of minus 16 as square root of 16, square root of minus 1. Square root of 16 is 4, square root of minus 1 is I. And we're doing that because we don't want to leave our answer in this unsimplified form. We always want to try and get our answer in terms of I. So actually we know that z plus 3 is equal to 4i, or z plus 3 equals minus 4i. So we're going to get our two solutions, take away 3 from both sides, minus 3 plus 4i, or z equals minus 3 minus 4i.